Graphs are tools that represent your data visually. They say a picture is worth 1,000 words, so graphs are tools that allow you to see your data more clearly and discern relationships more easily. There are 3 major types of graphs: line graphs, bar graphs, and circle or pie graphs. Today, we're going to be investigating line graphs specifically. Line graphs are used to show relationships between numbers. So if the data that you're collecting is a number, then there's a pretty good chance that you should be using a line graph to represent that data. We always are going to have variables in our experiments. These are the factors that are being measured. Our independent variable is the value that we know before the experiment is done. The dependent variable is the variable that is unknown before the experiment is done, and this is what we're measuring during our experiment. If we were going to investigate distance traveled by an object over time, time would be the independent variable. We know this before we start our experiment. The dependent variable would be the distance traveled. This is what we don't know, and we're going to find out as we make our measurements during our experiment. Time is measured in seconds in this case, and distance traveled is measured in meters. You can see that our data in this table is quantitative data. Time is measured in seconds, and you can see that each of these values are numbers, quantitative data. The distance traveled also, in this case measured in meters, is also numbers, quantitative data. This is why we're using a line graph, because line graphs are used to show relationships between numbers. So the best choice to demonstrate the relationship between the distance traveled over time is a line graph. When we construct our graph, we need to know that the x-axis is along the bottom side of the graph. This is where we place our independent variable. The y-axis is along the left side of the graph. This is where we place our dependent variable. So in this case, our independent variable is the time in seconds. This is what we started off knowing before we conducted our experiment. So we'll place that on our x-axis. Our dependent variable is the distance traveled. We didn't know this before we started our experiment. We needed to discover this as we measured our data during our experiment. So we'll place this on the y-axis. The next thing we need to do in order to set up our graph is to make our intervals for our x and y axis. If you count the boxes along the bottom side of the graph, along the x-axis, you'll notice that there are 25 boxes. Looking at our independent variable, time in seconds, our smallest value is 10, and our largest value is 50. We need to make sure that we can fit all of this data onto our graph. So if our largest value is 50, and we have 25 boxes along the x-axis, we can make each line along the bottom axis 2 seconds. There we go. We start at 0 all the way on the left. Each box is worth 2 seconds. We get all the way up to 50 on the far right side. Looking at our dependent variable, the distance traveled, our smallest value is 5, and our largest value is 25. If you count the boxes along the left side of the graph, we have 25 boxes. Since our largest value is 25, we can make each box worth 1 meter. So here's our y interval, starting at 0 at the bottom and going all the way up to 25 meters. Now we're ready to start putting our data points onto our graph. Let's look at our first data set. It's highlighted in red here. So we have 10 seconds, the object traveled 5 meters over that 10 seconds. So we'll need to move 10 seconds over on our x-axis and 5 meters up on our y-axis. This will give us our first data point here. The second data set is highlighted in green. In 20 seconds, the object moved 10 meters. So this time, we need to move over 20 seconds on our x-axis, and we need to move up 10 meters on the y-axis. This gives us our second data point here. The third data set is highlighted in purple. The object traveled 15 meters in 30 seconds. So we're moving 30 seconds over on the x-axis and 15 meters up on the y-axis. And there's our third data point. When we look at the fourth data set, we see that we need to move over 40 seconds on the x-axis, and we need to move 20 meters up on the y-axis. That gives us our fourth data point here. The last data set is 50 seconds and 25 meters. So we need to move over 50 seconds on the x-axis all the way to the right, and 25 meters up on the y-axis all the way to the top. There's our fifth data point. We're not quite done with our line graph until we've actually drawn the line. The line will just connect all the data points that you've created. There we go. Now you can visually see the relationship between these two numbers, how fast or how far this object is traveling over a certain amount of time. Line graphs show the relationship between two different variables, in this case, numbers, quantitative data. Depending on the data that you collect in your experiment, the graph can take on many different appearances. Some of the relationships that are shown have specific names. Some graphs look like this, like the graph we just constructed. This is known as a direct relationship. This means that as your independent variable increases, so does your dependent variable. So as x increases, so does y. Sometimes the graph can look completely different, going the other way. This is known as an inverse relationship. So as the independent variable increases, the dependent variable decreases. So as x increases, y decreases. You can see that these two lines have opposite slopes. Lastly, we can have a crazy graph like this, where your lines are going up and down all over the place. This is known as a cyclic relationship. In this case, as x increases, y will begin to increase, and then it's going to start to decrease. This becomes a repeating pattern. As you can see, y increases, decreases, increases, decreases. This is a cyclic relationship.